All right, welcome to our next video in the series. This is a lab for Snap programming that we call Ecosystem. The idea behind Ecosystem is it's a chance to practice using clones. We're going to have a great many clones on the screen. We're going to see them interacting. And like you might learn maybe in an environmental science class, we want all of the clones on our screen to reach some sort of balance, some equilibrium, which means that I want some of all of my types of clones, but not too much or too few of any one. So if you imagine an ecosystem that has plants, herbivores, and carnivores, well, plants are going to be constantly growing. They'll have a rate of growth. There isn't an unlimited supply of plants. Then you've got herbivores that eat the plants, and then carnivores that eat the herbivores. If we see herbivores eat the plants too quickly, the plant supply will get low, and the herbivores lacking food will die off. But if there is not very many herbivores, plants can resurge, and then the herbivore population can increase. So you get this natural ebb and flow. We're going to model this with Snap, and we are going to do it with 3 different types of clones. So I've used Pokemon sprites for this. Little Oddishes will be my plants. I've got Rhydons are going to be my herbivores, and then Scythers are my carnivores. So I'm going to go ahead and turn my little simulation on. You see all the Odyshes growing. There's my herbivore and my carnivore. Oh, it looks like this particular simulation, unless that, oh no, it died off. All right, so this happens sometimes. We'll try again. None of them went towards food. There we go. So we see the Rhydons interacting with the plants. When a Rhydon touches a plant, it will interact with that plant and start to reproduce. And we see when a Scyther touches a Rhydon, hopefully that happens right now. Perfect. We start to see the Scythers reproduce. And the way that this lab works is all you need to be able to do is make sure that your program can self-sustain for 30 seconds, which means at the end of 30 seconds, I should be able to see herbivores, carnivores, and plants all on the screen at the same time. And this means that you don't want them in there just permanently. You don't want them infinitely. We want them to delete themselves if they don't get to food soon enough. And if you produce carnivores too quickly, the herbivores will die off. If you produce herbivores too quickly, the plants will die off, and so on and so forth. So we see this balance is being reached, right? The Rhydons that don't find food are deleted. The Scythers that don't find food are deleted. Plants are constantly regrowing to make sure that there is food for the Rhydons, but it's not too ridiculous. We see the carnivore population swells here. Oh my gosh, one of the Scythers kind of fell on the Rhydon nest. That doesn't look good for the poor Rhydons, but as soon as it gets out of there, they should be able to reproduce again. Ooh, it's looking close. Looking close. Okay, I think they're, oops, maybe. Well, this could be the end for the Rhydons. Oh, there it is. See, they're back. And watch what happened there. As the Rhydon population dwindled, because the Scythers ran out of food, their population dwindled. And then when both populations went down, what happened? The Odyshes were able to resurge, or to return. So this is the idea. This is what we're looking at here. I wanted to give some recommendations for how to write your code. And here are my recommendations. Number 1, the default stage size is just too small. I recommend something larger. I'm doing 900 by 700. This gives your sprites enough room to work. If it's too cramped, there's too much variance. They wipe each other out. It's not good. So that's number 1. Number 2 is have your sprites move slowly. If sprites move really quickly, then they will just wipe out whatever it is that their food is. So make sure you have them move slowly. Then number 3, give your costumes clean edges. It can be really tempting to draw fancy edges that have points and dots and all kinds of stuff. But when we're counting on good, clean sprite collision, you might end up with awkward situations where one sprite thinks it's touching another sprite, but then the other sprite doesn't realize it's being touched. It can be very messy. So give your costumes clean edges. You can I grabbed all of these sprites off of the internet, all of these images. To get everything to balance correctly, you want to vary the speed, the starting health, the health gain, the spawning location, to help with survivability. So what does that mean? That means that, well, we want to give every individual sprite their own variable, their own health. Not plants. Plants don't have a health. They just get to exist forever. But let's say I wanted to come up with something for my herbivores. I would make it an individual sprite, and maybe I'd call it herbivore. I'm just calling herb health. Oops. Yeah. Okay, whatever. And then the idea is when I start as a new sprite, so when I start as a new clone, I should say, when I start as a new clone, I get to set my individual health, and this will be the health for my clone and nobody else. I might get to set it for something like set herb health to, you might want to do something like 300. Then as you're moving around, right, so all of these sprites, they just kind of move infinitely. Boy, this poor program's really bogging down because it's getting sluggish. I'm going to pause it. Whew. When I start as a clone, I got to start running around looking for food, right? So I might do something like forever, move, if on edge bounce, make sure I'm pointed towards a random direction. I should probably get a starting spot going, something like that. But then if ever I encounter whatever my food is, so herbivores eat plants, I probably am going to want to do something like this. Hey, if touching plant, then I get to have some more health, right? Like I've given myself more energy. So I can I can change my herbivore health by maybe 100, something like that. And every time I eat, I get to recreate. So we're going to say create a clone of like the herbivore, right? That's the thing I would get to do. But then every time I move, every single movement should tax my health. So while I'm moving, I'll say change health by -1. And you guessed it, if health ever goes, below 0, I delete myself. I ran out of food. Very sad, very sad. So this is the basis of it. And we're going to mess with, if you want to determine how well something survives, you can make it survive more by increasing its starting health, by increasing the amount of health gained, by picking up its speed. If something is being eaten too much, weaken its predator. That's kind of the idea. Spawn sprites in your stage carefully. So I have in my stage is who handles plant creation. I think that's a good idea. And then remember, you can use create a clone of herbivore, just never do create a clone of myself, because remember that can cause all kinds of issues. And then a great tip, this is something that's going to prevent a lot of pain, is there's this cool block called wait until. And if you say, hey, look, wait until not touching plant to get your health and reproduce, this is going to save you some trouble, because oftentimes the herbivore will step on the plant, see that it's touching it, and then the forever loop will run maybe a few times before the plant realizes it's being touched. So the herbivore goes munch, 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 and instead of eating one oddish creates one herbivore, we get 3 herbivores out of it, and the screen floods, and it's terrible and awful. So you don't want to do that. So waiting until not touching is a great tip. This one's really fun. Kids really like it. Be creative with what sprites you pick. I think you can do a lot of cool things. Please email me if you have any questions, if you need any help, and happy programming.